today they are even higher. I mean, one could try to argue, but inference is cheap. Is it really cheap? Maybe not, and I'll very quickly argue again without figures, but I'll very quickly argue why. I mean, if you look at any successful AI model cycle, typically give or take 15%, it could be plus minus 5%, but 15% of the cycle goes in training, and the 85%, the remaining 85% goes in inferencing, because that's the actual lifespan. I mean, trading is purely an overhead, right? Ultimately, you want to do inferencing, and you want to maximize the inferencing, to be honest. I mean, if you can train for with 5% of your cost and then inference for 95%, which probably means you have a long running model that held true over a period of time or was very applicable for a lot of business problems, you are a happy entrepreneur, and you are a happy researcher also, I would say. So hence, inference, even though one piece of inference is typically not very costly, but we typically, I mean, you would have to eventually go through a lot of finding all those parameters, hyperparameter, I mean the parameters, all these factors, and eventually it turns out to be very costly. As you can imagine, the main cost is in inference, even though the trading cost might be upfront, but in the long run, the main cost is in inference, carbon cost, monetary cost, everything. So eventually, this is where you really want to optimize on. So with that, that perhaps acts as a motivation in a way, right? So with that, I'll request to flip over the slide to, and this is the why that I covered at a very high levels, but I'll go into the more of the why on slide 3, which is the next one. So selecting the right LLM in a multi-LLM environment is very important, right? Because obviously you don't want to compromise on the quality. It's not like you want to reduce your quality for cost, for carbon, for whatever. But at the same time, you cannot you cannot have to something too expensive either, right? For example, if and this started at Stanford. So by the way, this talk is based upon a Stanford Frugal GPT paper, and then the way we adapted it for operationalization, because that was just an academic thing, and this is operationally how do you architect it and so on. But if I look at the underlying philosophy, you really cannot have a machine that takes up all the energy and gives an output if you can afford to be less costly, because for all you know, it might actually end up doing 10x queries if it's like one tenth costly to come up with similar results. So that's the underlying philosophy. And then uh, can you really locate the, or guess, predict, whatever, the the LLM model, which is the smallest possible, however, can give a result that's ballpark at the larger one, right? I mean, let's say you take a small model, 7 billion parameters, not 13, not 70, whatever. And if you can say that for this query, that 7 billion parameter model is going to give a result which is, give or take of similar quality to the 70 billion parameter one, you would go with the 7 if you can predict that in advance, and if that prediction cost is not very high, right? Because typically you'd end up saving a lot. So that was the underlying philosophy of Stanford's Frugal GPT. I'll touch upon it because without that I cannot cover this talk. But again, my job is not to extensively cover that. I've given a citation, right? If somebody is really interested to know the every integrity of that, they can go up and read, and I'll give the citation down the line. However, I'll describe the ballpark and what did we do to make that philosophy, which obviously we find is very relevant, how to do that philosophy, make that philosophy operational. And being in the Accenture software engineering labs, one of the stresses we have is on sustainability. So while that work focuses purely on the cost, as in the monetary cost, we also have to map to carbon, and cost and carbon don't really add up immediately. Again, there are nuances. That's not the topic I want to cover today. That's not the focus for today. But if you are interested, you could go up, and there are ample papers and ample other kind of literature available that describes why cost and carbon are not linear. I mean, why carbon is not just a factor of monetary cost, right? So there are different power sources, and there are different ways that energy is generated and so on and so forth. But that's a different topic of discussion altogether. So here, as you can see, there are multiple tasks in this business problem: task 1, task 2, task 3, and there are different LLMs available. So for each task, which one do I choose, right? So essentially, that's what I'm going to do. And what are the factors that I look at? If I please could go over to the next slide. What are the factors that I would look at? There are several factors. If you look at the right hand side diagram, obviously it's a business problem, right? And I've put that right in the center, but there are multiple factors that you have to trade off. So there's a question of accuracy, which is quality. And then there's a question of performance. I don't mean the ML performance. I mean, how much resources they burn in that sense. And so it's an overall performance. There's a question of sustainability. And rather than having optimum on one thing and going gung ho on everything else, for all practical purposes, you have to like look at it, all the aspects. And that's a fundamental premise that this research comes from. And if you look at the left hand side, there's some examples which is pretty much 1 year outdated, because that's the time we had prepared this slide, but it was very relevant and the philosophy again holds. So I didn't really update this slide because in principle this slide will still hold. So LLMs are more power hungry than traditional models, as we know, and there are different kinds of there are different kinds of and open source is a different story. Or there are things with low API access cost. There are things with high API. Mean a large parameter. So, for example, from this diagram, if you look at GPT Neox, it's a high API access, high cost API access, but it's less than 100 billion of parameters. Or, for example, if you look at GPT 3.5, that's the time when GPT 4 was there, but I mean all these GPTOs were not there. So, low cost API access was less than 10 million. Yeah, I'm not sure. I think I was thrown out for whatever reason at random, but to continue what I was saying, I don't know which point I was thrown out. I just realized.
You were talking
Venki, was it?
about the various GPT 3.5. I think so. After that, you were kind of dropped off
Uh,
when you're talking about GPT
okay. How
3.5.
long was I? Sorry, how long was I disconnected? I just realized.
Probably about
Was it
30,
long?
40 seconds, maybe.
Oh, pretty long. I didn't even realize that. Suddenly, I thought. Suddenly, I saw myself out, and the screen went out for a moment, but then I realized because it usually goes out quite some time after it disconnects. So yeah. Okay, so I'm picking up an approximate point. So all I was saying, I mean, long story short, is the monetary cost of access obviously depends on the charging model that the companies, the providers give for to an end customer. But that's not necessarily a linear factor of the number of parameters. What the factors are, obviously I cannot comment because each company will have their own charging model. But for all practicability, for all practical purposes, it's not a linear thing. And then obviously open source is a different ball game. So now when Stanford, if I could go to the next slide. Yeah, next slide, please. This is, yes, this. So when Stanford, proposed their frugal GPT, and I'll go a little more, quite a bit more in the details of that. No, not that. The one with the diagrams and figures, the plot. Yes, this one. I don't know if there's a delay, but I mean this one. So Stanford optimizes over the selection of LLM APIs and prompting strategies to achieve substantial efficiency gain. So this is pretty interesting because if we think of the way we use LLMs, it starts at prompts, right? So can you do something right at the prompt itself? And then once the prompt has been made appropriate, can we have something called LLM, LLM APIs that an optimal selection of LLM APIs. So within the labs, we have worked on prompting strategies also. That will not be the focus today. However, that could have been a focus. But we shall rather describe the operationalization of the system. Actually, here in the labs, we have created something called a smart prompt advisor that look at the context, uh, add, subtract, and add it, modify automatically stuff that that might have been added, should have been added, etc., and so on and so forth, right? And eventually optimize for the prompts. But I'll just go into the bigger picture today. It's just a 45-minute talk. Okay, so Stanford's approach in frugal GPT, they look at two things. One is cost savings and how the performance trade-off because of the cost savings, right? And if I have to flash one of the results, if I look at the table here, they had a data set. They had a few data sets, and interestingly, the best individual LM was not GPT for all of them anyway. If you look at the third row in COQA, it was GPT-3. Now, what they did is they tried their mechanism, which is a pipeline that I'll kind of showcase soon. But they tried a pipeline and tried to show what's the cost to reach the same accuracy using their frugal GPT mechanism, right? And if you look at this, the cost for headlines data, the base individual LM in this case GPT-4 took 33.1 units, while frugal GPT took 0.6 unit, right? So that's a massive cost saving. Similarly for the second one also, right? I mean, the first one was 98.3% cost saving. The second one was 73.3% cost saving. And then if you look at the third one, that was also 59.2. So these are three examples, but the general trend is there are major cost savings by taking the frugal GPT into consideration. And by the way, one thing for sure, typically, not always, not with a guarantee, but quite often, cost saving does lead to carbon saving, not always. Here we are looking at the cost in the sense of operation cost also. I mean, this is probably linear, somewhere like correlated with the operation cost. It is a monetary cost, right? So I'm not commenting that it's exactly linear or something, but there's got to be a correlation, right? In that sense, I mean, there is a correlation. So in that sense, okay. Now, if I look at the left-hand side plot, the left bottom plot, so see how the accuracy grows, and there are different these LLMs mentioned here. But in the frugal GPT mechanism, as they increase, the model accuracy shoots up to an extent, right? GPT, no, chat GPT, no, GPT 0.86 in terms of, again, accuracy is a pretty bad term, but let's call it performance. Like I think they mentioned the term accuracy, which could have maybe be an F score, but am I back? I have no idea what's happening because I've never thrown out
I
like
think
this
you
from
got
Zoom.
disconnected again. Is it maybe a network issue?
Hello,
But yeah, please continue, Kuntal. We can hear you.
hello.
Yeah, I can hear you, Kuntal. Please go ahead. Kuntal, please go ahead.
Yeah, I'm really no idea. This is the first time it's happening with Zoom with me. It never used to throw me out. The first time I'm seeing. I do Zoom meetings from my mobile pretty often.
Okay, please continue.
So sorry. I just have no idea what's happening. Okay. So anyway, to continue, again, I don't know which spot I left off, but let me reiterate through this. No, what I was saying is, for initially, if you look at the left-hand side bottom, chart, the accuracy shoots up pretty fast. And I'm saying accuracy because they use the term accuracy. I don't know whether it should have been a F score or what, but I'm just assuming all the class balances, everything they've taken care of. It's from Stanford, so I trust them on that. So uh, from it goes beyond 0.86 pretty quickly, right, with a pretty low model. And then even if as the cost increases, the x-axis is cost, right? Even if the cost increases, no matter what you try, I mean GPT-4 is very high on the cost. If you see, it's on the right hand side. GPT-3J1 is somewhere here. So beyond a point, even with increased cost, that line doesn't even shoot up beyond 0.88. It actually stays close to 0.87. So the performance increase is very limited. By performance I mean accuracy, I mean if score, etc. Performance gains are very little beyond a point. So the question is, can we reach that that point of stepping off, where the gradient falls off, by using the cheaper, the easier, the less costly LLMs, right? Which are mostly on the left hand side. That 0 to 10 bracket, typically you see a lot of LLMs in this case. So can we do using that? And that is a gain. That's a goal over here. Now the approach overview, I'll go in detail, but generally that has been tried with a set of repository of good prompts. Again, I'll come in the next slide on what are the prompt strategies, and a good repository of LLMs, not just a GPT-4, but quite a few LLMs that are like, some are cheaper, some are more expensive, and then finding out, or at least being able to predict what's a good combination of a smaller prompt. Small is not necessarily small in the length, but small in the expense. So smaller prompt and the most affordable LLM. If that can be done, then that's a good output solution as an LLM and prompt.
Did we lose Kuntal again?
Yeah, looks like Venki.
Back.
Oh my God,
Yeah,
this,
Kuntal,
this
you
is getting
back?
unbearable. Yeah, I'm back, but it's the fourth or fifth time it happened. Zoom is very stable. Is it me or is it anybody? Is anybody else experiencing this, or is it just my network or something?
Could be
Because
because
this
you're
has to be a
joining, all
network.
of us are joining from laptop, so I don't know. I mean, that's the other difference that between you and us. So
No. I typically join from my mobile. As I said, my laptops give issues with Zoom. Even my personal laptop has an issue with Zoom. That's why I couldn't use my personal laptop. So Zoom I typically do from mobile, and this never happens. I mean, I have done multi-hour meetings. It never happens. I don't know if my network is creating an issue or what. I can't imagine anything else. So if you please go to the next slide. I mean, I could try the 4G instead of my Wi-Fi. Usually it's pretty stable. Yeah, thanks. So Stanford uses 5 building blocks to construct their frugal GPT. Now, the first one is selection of prompts. So two of them are prompt related. The first two. The first one is selection of prompts where they retain a small example, right? Few short type of examples. Now the challenge they solve over there is which is the prompt for keeping. So that was that's the challenge with that. That's the one with here, right? Which prompts to keep. So that's the prompt selection thing that they do. The second thing their pipeline is query concatenation. So if multiple prompts or queries segregate the responses and give back. So that's the second step that they do. The third one is a completion cache. Now that idea is fairly straightforward, but it's pretty neat. So they use a store like a cache, right? And then they reuse an LLM API's response for similar queries. So again, like any cache, there'll be a hit and a miss, right? So if it's a cache hit, then the backend engine is not even hit. Now the actual API, the LLM API is hit only if a cache is missed, right? So it invokes the LLM only once if multiple users search for the same. And that's very common. If you look at the trending searches, for example, and so on and so forth. I mean, I'm taking searches as an example, but if there are trending searches or if there are typical tasks that someone needs to complete, or think of let's any company like even mine or somebody else, right? Going to clients and creating similar prompts, right? That need to repeat multiple times. So that's pretty easy, right? They can just use this as a generic answer. Now, if it's personal data or something, that'll be a different story. That I'm pretty sure is an operationalization question, even though it's not addressed here. But it's a general truth. So it's like a smart caching for prompts. Then there's LLM Cascade, right? Where it employs different LLM APIs for different queries, and it uses inexpensive LLMs with similar or better performance that are earlier in the cascade. So the cascade is kind of created like this. The cheaper ones with good performance or expectedly good performance are put on early in the cascade, right? Now there's a predictor that they have used, right? Which they try to predict, is this query going to do well? And it's a very low cost predictor. Is this query going to do well with this LLM, right? And if the low cost predictor says yes, then they hit early on the cascade. If it's no, then it's not then they don't run the LLM, right? Not the cheaper LLM. It's just a question of classification. of whether it's the prediction, right? Whether it's like regression, what's the expected scores of this? I mean, what's the expected quality of this thing? And then if the regression gives a beyond a threshold number, they say yes. So they hit a very cheap one early, and then maybe a slightly heavier one next, etc., etc. So unless every predictor says no, in the sense this query cannot be served by this LLM either, they don't even have to hit the heaviest one. They can stop in the earlier cheaper LLMs, and then that saves a lot of cost because the cost of classification is not high. That's how they have designed this, right? And then finally, a model fine tuning, which is also pretty interesting. I mean, we all talk of fine tunings, but what happens in model fine tuning is the uses the expensive LLM's response to fine tune the less expensive LLMs. So, am I frozen? No, thank God.
So,
Sorry. Yeah. Yeah, this is giving a bit making me nervous, the amount of freezing and disconnection. So all I was saying is this is pretty neat. What they do is they take the more expensive LLMs. So I'll give you an example, even though it's not from their book, but let's say there's a query that you see ChatGPT, GPT 4.0 will do it pretty well. You take it, but rather than just giving the response back to the user, you invest a little bit more. You take a much cheaper LLM, which I don't know. I'm just again throwing examples. Excuse me for that. Let's say you throw Llama 7. Let's say Llama, right? For example, it's 7 billion parameters. And for whatever reason, you think that this will do well over GPT, pretty much as well as GPT 4.0. It's some more fine tuning, maybe with that problem, that domain. You train with that also. So over some iterations, the much cheaper model becomes a little more expensive, obviously, but remains a lot cheaper than the heaviest model, but remains with similar kind of performances, right? So beyond the threshold, you can start using the cheaper one. So over a period of time, after this training, the cost will go down. So these are the 5 techniques that are at the backbone of this thing. Now, what we do in our control plane is we take that, right? We take all of this, but then we also add the cost and carbon. I mean, we also add the cost factor, but along with the carbon factor also in the overall thing, right? So Stanford's Frugal GPT. If you go to the next slide, please. Not the what. I mean, the slide after that. Yes. So what Stanford's Frugal GPT does. So as I said, right, we are trying to optimize the cost and uh, quality optimization, right? So what Stanford Frugal GPT does, it teaches us trade-offs are important because they have empirically shown that. They provide us trade-off mechanisms. And what are the 3 trade-off mechanisms? One is prompt adaptation, like we saw in these first 2 things, in the first 2 boxes, right? Prompt selection and minimization, where we club prompts. LLM cascading, where we have configured uh, and then also caching, because it actually it's a part of cascade in a way. And then finally, LLM approximate train a cheaper LLM using an expensive one initially. So those are 3 mechanisms that I have shown. But to this is getting into the nerves now. I'm really scared.
We didn't lose you for very long, so just continue, please.
Yeah, okay. So okay, I'll just continue then. So what we do is, we have to look at client experience, because this is just a backbone, right? How do you make it useful? There's a question of smart prompt advisory, where you can have, like, not just small prompts, but the right prompts, right context. Then there's been abstracted API interface, because it could be prompt based interfaces. Whatever.
Uh, Kuntal, we're not able to hear you.
Oh, what
Maybe you
now?
may just try just switching off your video and just, if it's a network issue, then at least that let audio continue. Maybe you could just try that.
I am sorry. Am I audible?
Yeah, you are. So you may want to just switch off your video and see if that helps. If it's a network
I've
issue,
switched
that
off.
should
I've
just,
switched off.
yeah.
Yes, I've switched off, but ah, it is network issue. It is already switched off. Let me just shut off. Can you hear me clearly? Then just shut down my Wi-Fi.
Uh, he said he's joining back, right?
Yeah, yeah, yeah.
Yeah, yeah. Okay.
It's here, it seems.
Yeah, yeah, I'm back here. What I've done is here automatically switched over to my 4G. So I just switched off my Wi-Fi. It's probably a network issue, which usually never happens, but Murphy's law. Am I audible now?
Yeah, yeah, you are. You are. Please continue.
Yeah, yeah. Sorry, I have a pretty good Wi-Fi. It's just Murphy's law. Can't help it. So I just the network, the 4G. This building itself has a tower, so I'm really hopeful it will stay. Okay, I can't see the screen yet. Have you been sharing?
I'm sharing. I've not changed anything, so I presume it will just take a
Okay.
minute for you to load that.
Yeah.
Maybe it's 4G. It's taking time. I have no idea. Maybe it's 4G. So okay, I can't even see the screen, but which slide I cannot. God.
So we're still on that
And I
Stanford Frugal GPT, the trade-off that you were talking about, and the
can see now.
Accenture's
I
approach. Yeah.
I can see now. Finally, it took time, but I guess it's because it's 4G. But I can see now. Let's hope the 4G doesn't create problems. Okay. So, so I was talking about, I think, yeah, client experience, smart prompt advisory, abstracted LLM API, I think these three were probably covered. LLM pipeline composition, because not every client, not every business, not every end user will have all the LLMs. So, given a particular situation, what are the LLMs that exist? Can you benchmark them? Because whatever, and then they call LLMs, right? So whatever they are, they need to be benchmarked. Now, some benchmarking has been done by Hugging Face, but that to minimize tick, and there's no cost. I mean, there's no carbon benchmarking at all. So we did all of that internally, right? I cannot share those numbers obviously, but internally. Some cost benchmarks also that Hugging Face has brought forward. All of that. So that it will be taken into account. Then the question of analytics and monitoring. Observability of reps. And the questions
Kuntal, sorry to interrupt.
what is up?
Kuntal, sorry to interrupt.
Yeah,
Your
please.
voice is really breaking. We are barely able to make sense of what you're saying.
Oh, gift.
Uh, you may have to probably switch back to Wi-Fi and just try it again. Maybe give that a shot again if you don't mind.
Am I audible?
Yeah, now you are back. Now we can hear.
Perfect. Please.
Yeah, yeah.
Okay.
Sorry, participants.
Yeah, I'm back to my Wi-Fi. I'm really sorry. I know it's probably being watched by a lot of people. I really apologize to the audience because this is sincerely not what I had expected. And so Murphy was striking because my network is pretty good. My network provider is pretty good. Usually they do a good job. It really
We
happens.
can hear you very clearly now, Kuntal. So maybe continue, please.
Yeah, I just hope it doesn't drop off. All right. So I guess, yeah, I'm losing time. I lost a lot of time also because of this, at least 5-6 minutes for sure. So LLM pipeline composition, I think that I just covered that. I don't know how much was hard, but all I was trying to say is you hit the cache first, then the cheaper ones, and then the more expensive ones. But the clients and the end users might not have everything. And there's a question of benchmarking because you might have to benchmark what you have from multiple aspects, right? One is from the cost aspect, the other is from the carbon aspect, and then obviously the quality aspect is there. So Hugging Face, etc. There were a lot of and others also, quite a few others have a lot of benchmarks on the quality. The cost is relatively rare, and carbon is practically nowhere else. But since those are the factors we work on, so there are benchmarkings that we have done because of this, right? Then the question comes of observability. And when I say observability, what I mean is the monitoring and analytics of the LLM ops. So for example, what is happening in this Zoom call right now, I'm dropping off, joining back. Now, if that happens for whatever reason, if that sort of thing happens, it's an extreme example, but if that sort of thing happens, uh, with some client running with a business running for their end customers, let's say some processes, some SLA, is going to be a disaster, or for whatever other reason, right? The point is, if something slows down, if something is taking more time than expected, something has some other issue, right? Connectivity issue, cost issue, and then there are carbon monitoring factors also. I'll give an example, even though I won't get in detail. But let's say for the carbon, how do we? One of the ways to do carbon, for example, is to look at things like, for example, electricity maps. There's a company called Electricity Maps that has a live carbon feed, right? So they monitor different data centers across the world, and what happens over there is they try to put the source of power, the source of energy for each of these data centers by mostly operating at a city level, right? So, what that intern tells us is inside the system internally is, even if two data centers are quoting the same monetary cost, I should still go to the one with a carbon cost, lesser carbon cost, right? For example. So all those things are taken into account. So and all of these need to be a part of the LLM ops, right? If you have got, where do you, for example, if you're doing a hosting in-house of your LLM, where should you host it, right? So all of that needs to be taken into account, because that makes a lot of difference in terms of carbon credits, right? So observability will take all of that into account. Benchmarking is something I described just a little back. And then you have to obviously fine tune for businesses. This is something we all understand. There's no real research that we have done in this. It's typically, RAG and graph RAG and so on and so forth. And then how do you put it on certain kind of infra? So those are the typical, the key questions. For that, what we proposed is an LLM control plane. Achha, can I go like 5 minutes extra till 10:50, because I know I'm supposed to stop at 10:45
Yeah, please continue.
India
Please, no problem.
time.
Yeah.
Since I put 10, if I'm not audible, just type, I guess.
Now
You are audible. Please continue, Kuntal.
Okay, so then I'm going to tell 50, yeah, and then maybe keep the last 10 minutes working
Sounds
with.
good.
All right.
Sounds good.
Otherwise, I'd be out of time. We lost so much time because of the network. So sorry for that. But anyway, so there's this control plane that we have, right? I mean, in the slide, there's this control plane that we proposed. And this control plane has these few layers. If you look at the right-hand side, they have to interface with the client through APIs as well as through chat interfaces. Then that interfacing has to convert that by optimizing prompts that I mean, clients will probably specify in some sort of natural language. And in case of prompts, you have to optimize those in terms by making them smarter prompts, in the sense contextualized and optimized for whatever LLMs are underneath and so on and so forth. So the research goes in that, and then there's abstracted APIs which might actually have you might have to abstract the APIs, because if there are multiple LLMs underneath, they all might not take the exact same interface. So you take the client's API. I mean, you take the client's call to your API, but then you map into the LLMs that you're supporting underneath, right? So that happens here. And then LLM service composition and orchestration is this is where you create your cascade, and you might in fact dynamically alter the cascade also, right? Something happens and you change the cascade on the fly based upon your monitoring and observation, right? Because all the monitoring and observation happens here in the composition orchestration. I mean, you create your cache, you create your cascade, you operationalize it. Things go great, awesome. You enrich your cache here because of your monitoring and analytics. If you see that something is going wrong, this is some LLM, this is some provider is backing off, or your own data center is going down that hosts some LLM, right? You might want to eliminate, resurrect, alternate your cascade on the fly, etc. Right? All of that happens here. And then LLM benchmarking and fine tuning. This is where we create all the benchmarks for LLM, how costly, how expensive it is. Fine tuning, obviously, we all know fine tuning, right? There's not much to describe. But eventually, when we create the cascade in the third layer, the LLM benchmarking and fine tuning, the output of benchmarking especially, and obviously, if you're fine tuned for some business domain and you're going to solve for that client, then that also is taken care of in this layer, right? And then the lowest one is next to the infra. That's not really our focus. We just have to be compatible. And then there's a vertical layer of manage, observe, and regulate, right? We have to manage the whole thing. We have to be compliant with everything. Then there's a question of, the responsibility questions typically, that happens over here also to the extent we need to. Now, all of that is embedded inside the control plane. So the job of the control plane is to consume, the enterprise users and applications, let them control, and give back the observation reports. So that happens with the upper layer. And with the infra, which is the LLM, the data, the next in hardware infra, so to speak of, the services, whatever platforms they are. Again, there's a consumption from both the ends. The control plane goes and optimizes the configurations. They orchestrate in the sense, it has to orchestrate the cascades, it has to orchestrate the queries, etc. And then it controls it overall, right? And then does, for example, monitoring, analytics, observing, and then eventually the feedback loop comes back from the observations, and all the outward loops are optimized, right? So that happens at this layer, right? So you have, like, steps for everything. Some of it is proprietary, that cannot be shared naturally, but these are the directions of research that we have followed here. Maybe in the interest of time, I'll just keep this slide since I'm anyway running a little delayed. But essentially here is how the loop works, and this is something I've been through, right? The core constituent will have a smart prompt advisor. So if I go back a slide down, sorry. I'm sorry. Actually, since I was looking at my version also, I just had, like, no, not the how, the slide right after
Not the
this.
how, before that, after the how.
After. Sorry, I had
This
actually,
one?
like, flipped my own slide. Yeah. This is, I'm not seeing to it on the mobile. I flipped my slide on my laptop, right? And then I'd forgotten that I asked to see the slide. Sorry, I forgot to ask the still. So the point is this, right? So the core constituents of cost and carbon, they still remain the same. It is still LM fine tuning. It is still LM benchmarking. It is still LM cascade optimization, and it is still smart prompt advisor and adaptation, because the prompts need to be, like, contextualized. So that engine, the core engine for the how, remains the same. Now I'll showcase what the architecture components are that we have used to implement this. So if you could go another slide down now, please. So just 4 more slides that I need to cover. So hopefully, yeah, 2 minutes per slide should be fine. Now for
I'm on the
so
LLM
here,
benchmarking slide. Is that the one?
yes, yeah, this is the one. Yeah, this is the one. Yeah. So like LLM benchmarking and LLM fine tunings, right? So these two things enable knowing the models better, because with the LLM benchmarking, we know how the model is going to perform, right, for that domain, business domain, for that task in that domain, and for that given infrastructure. So that these three things we need to address. So whenever we have a problem, we have to benchmark at 3 dimensions: the task that you have, the domain that you have, and the hardware that you expect to run on. Hardware can be, again, Intel, AMD, whatever, right? NVIDIA, whatever it is. Task, it depends what the task is, right? It can be all the way from your healthcare to sarcasm detection, I mean, NLP tasks to whatever, right? But all these tasks, right? It could be image detection, right? I mean, we've tried with quite a few tasks. And then the domain will be the business domain, and mine across multiple domains, the same piece of thing might have different meanings. So you actually have to take the domain into consideration, because that sets the context. So these three things we have to benchmark against. And along which dimensions? In 3 dimensions: the cost, carbon, quality. So this is like a 3 by 3 matrix, right? So on one side, we have got domain, task, infra. Let's say 3 rows, for example, and then maybe, quality, cost, carbon, 3 columns, for example, right? So you create that matrix, and then eventually you'll have a total optimization system which will take all of these three things for each dimension. Sorry, all of these 9 things, right, in a way. So you look at all of this and then eventually have a joint optimization, right? So there are ways to do that. We are doing TopSys, but yeah, let's not go into that for now. So if I then the LLM fine tuning is something I've described before. But if I look at the architecture below, so in the Accenture domain and task repo, we look at retail, finance, so all of these domains and then tasks within this. And then on the left bottom, we've got LLM providers and API model demo, right? So I've got the different LLM models. We take all of them, and then obviously there are infra inputs, right? Which can be ops parameters, ops interfaces such as hardware type, size, speed, latency. All of that will come in, and they'll be fed in 2 ways into the 3 benchmarking modules we see right middle. So what are the 2 ways? One is the raw form, right? And the other is without the best possible fine tuning. So we look at the raw, we keep the raw version, that in the worst case, this is what it is. And then we have a full fine tuning. And then say, look, for the best case fine tuning, this is what it is, right? I mean, in the sense, again, the three same benchmarks, but the best fine tuning that we could get. So we keep both, right? And then by this, over a piece of, right, a set of offline processes, we build up domain task infra registry for model and API. Right. So this is a piece of knowledge asset that we create internally. Again, these are internal proprietary assets, but it's a piece of IP. But this is something we create over a like whole bunch of experiments. And then this obviously can be consumed by the online processes downstream when we do actual operationalization, right? So it's the first step, right? It's one of the contributions that makes the operations better. So to carry on to the next slide, please. I'll just touch upon this slide because this is, again, it's not like, but all we are trying, we try to do some stuff on the Intel family, etc., etc. And then if you look at the diagram, right, let's not worry about the text on the left side. On the right side, if you look at the figure, the diagram, so on Intel Ice Lake, right, we could actually see GPTJ inference performance was like pretty high. So that so no, I mean no, it's the other one. It's the Habara Gaudi 2. Sorry, it's the Gaudi 2 that was pretty high. In the sense, the lower is better because the quicker ones are better, right? So the lesser time you take, it took 14 seconds. Yeah. So the lesser time you take is the better. The higher time you take is worse. So we did all these experiments over for benchmarking over different quality, right? Different cost, quality, etc., etc. And we found this. So to carry on with this, let's come to the next slide, please. Great. So selecting the right LLM for the right task and composing the LLM cascade for end-to-end solution development is the next step. Now, since we have done the benchmarking, we have a pretty good sense by now what sort of LLM will be good if we can identify the task and domain well. Hardware is given to us. Task domain typically comes from business. Task we might have to map into a task from a task description, right? So again, that will be a typical usual mapping. It will be usual mapping from text to text, right? Can be as simple as cosine similarity or embedding based similarity. So using that we can find out that, and then we compose the LLM cascade on the fly because we know what's the set of the minimalistic, the cheapest ones that are that tend to do well with this, and we can have a long cascade. It's fine because right, even if you have a longer cascade, it'll anyway not infer for everything. It'll stop at the earliest one, which is good enough, which is beyond the threshold, right? So obviously, if the client might have a restriction, I don't want any cascade more than four different LLMs. It could have a restriction or cap like that, but otherwise it can go to an extent, right? And LLM observability and analytics, will happen because it implements observability here in the left bottom thing, right? And analytics happens there, which is fed back by the LLM users reported for observability. So that's the monitoring and analytics parts, right? And the prompts also go into that. So in a way, that's one part of the world. What are the two blocks on the right hand side? One is the LLM pipeline strategy engine, which selects the LLM based upon the domain, task, and prompt, and that uses the benchmarks that we created, right? And then creates a cascade using that on the fly, like I said, right? So you can logically there are two blocks. One is the cascade select the LLM selector and creator. The other is reporting and monitoring. So those two things happen over these four components. And then heading over to the final slide, the system prompt adoption and advisory. Again, there's a full, the whole smart prompt advisor engine that we have developed in house, right? So prompt contextualization and augmentation happens there. So it contexts are put in the prompt, right? And the prompt concatenation is done. Prompts are simplified. So by the way, this is another piece of thing. What's the simplest prompt that you can have across multiple prompts, which is inspired by the Stanford GPT, but obviously you have to do a realistic thing of this for a given task and a domain. And eventually, we can cluster pool cache for reuse of prompts, right? Because again, the caching is not exact, right? You can have approximately. So rather than having a precise query, you can actually look at paraphrases and like semantic similarities of the inputs. So there's a layer that happens over here. Again, it's a part of what we did, right? So the semantic similarity of caches, if it's an exact match, it's an exact match, right? But otherwise, semantic similarities or paraphrase detection algorithms are kicked over here, and then we cluster the cache prompts based upon that cache prompts, and then eventually that is what is hit, that is what is put at the top of the cascade, because that's how your cascade should start. It should always start with the cash. First time it will be a miss, but second time onwards it will be hit or miss, whatever. So this is the broad story. I know there's a ton of like intricate pieces of research that have gone in. Some of it is proprietary, so I cannot disclose it. And I know this is ACM, so it's a community where people love the openness. However, the reason I still chose this is A, because it's a very relevant piece of work today. B, it's something which with a lot of practical use, right? Obviously, in ACM kind of bodies, we do a lot of theory, but the practical side is also like something that is obviously of prominent importance. So because of all of these reasons, I thought it will be a very interesting piece of thing. And thirdly, it lies on a very interesting intersection. This is neither core AI nor traditional software engineering as we know, right? It's on the edge of the two things. So how do you marry traditional software engineering? I mean, you take the concepts from there along with AI is what I really wanted to cover here. So that's another reason I chose this talk over, let's say, research papers and so on and so forth. And so with this, I wrap up. In the next slide, I have my contact information, if that could be flashed, Venki, and I'll be open for questions now.
Thank you, Kuntal, for walking us through a very interesting topic. None of us, I don't think many of us may not have even thought about this angle of looking at, the overall cost. We use these ChatGPT tools very, fairly frequently, and we don't really give the cost and the carbon footprint as one of the aspects to even consider. So thanks for at least sensitizing us to the fact that, this is a very important aspect. Let's throw the floor open for questions. If there are none, then I have a few questions, but I'll hold off for them till we hear from the audience. I'll stop sharing so that I can see the chat box. There is one question. No, there are no questions. Are there any questions for Kuntal? There are none in the chat box. So let me quickly ask one question that was kind of bothering me a little bit. So
Yeah, please.
So, Kuntal, see, you do this, you talked about this LLM benchmarking and fine tuning, right? Given that these tools are also, the AI LLMs are also evolving very rapidly, the accuracy, the domain, the task, the infra, whatever you need are fine, but the accuracy and other things are obviously improving as we go along. So, how frequently do you need to keep benchmarking and fine tuning? That's one first question. And kind of follow up to that is, does it impose an additional cost on the overall infrastructure, and how long does it take to get this cost to get amortized?
Yeah,
Any
that's a
thoughts on that?
yeah, that's a fantastic question. So again, see, since we typically spend 15% of the life cycle in training, and the rest 85% on inference. So even though we don't have a fixed number, but the gut is, if we can be within 5% more, which is 20% 80%, then it might still make sense because of the major cost and major carbon saving that we end up getting, right? So that's the first answer that I have. Second, what's the right periodicity? We still don't know, but it's an ongoing process without a question, and then newer models emerge, and it's an extremely rapidly moving space, right? So now that we are going into the agentic world, this whole work might
Yeah.
disappear for all I know, with the philosophies will remain. The beauty of this thing is the philosophy are horizontal, right? We still have to do the same cost, carbon, and all this benchmarking for the agents as they become more standard. All these lang chains, and I mean there are a lot of things, right? I don't have to name, but we all know there are so many agentic frameworks, platforms coming up rapidly. So we have to take the same mechanism, the same workhorse, the same engine, etc. underneath. Repeat the process, have a similar repository. Because of this experience, we know what to look for.
Yeah.
But then the numbers might be fresh, and we might have new fresh surprises that I still don't know of because of agents and everything.
Right.
Yeah.
Great.
I
Thanks for
have,
that.
Venki, I have also one question. Maybe you can go ahead, and at the end I
There
will ask.
is a question on the chat bot. Can we go do that, and maybe
Sure,
then take your
sure.
question? Is that okay? Okay. So there's a question on the chat bot. It says, we tend to care about carbon footprint, where there are still some players in the market who really don't care about carbon footprints, and hence have a higher probability of creating a better model. So it's asking a fundamental question: why really care about carbon footprint? In a sense, if I were to paraphrase it, my interpretation is that does carbon footprint, does it constrain innovation, or arriving at better models? I think that's the question, if I will just paraphrase it.
See, we are talking of operationalization, right? And there are several of these parallels available. But like I said, right, training is typically 5 cars lifetime, and if that's 15% of the process, so you can imagine what an inference is for a typical model. So I've seen like papers that say training is like a full flight from New Delhi to Los Angeles or San Francisco. So they're very very expensive, right? They're very very expensive. So and if we do this for every single thing that we do, I mean, think of your 5G jackets where your left hand talks to your right hand, and then if they start inferencing, think of the scale for let's say 200, let's say 2 billion people. Forget 8 billion or 25% of the planet. Think of the scale. If we don't do carbon today, and if we look at the way that the global warming, I don't know whether it's a reality or not, but at least I perceive it as a reality. The way that it's happening, we are going to be in deep trouble. So it is really critical. Forget the carbon credits, right? For today, we are just thumping our chest, trying to be an early mover by saying, "Oh, look, I have a lot of additional carbon credits. I cannot sell that." There'll be a day when if you don't do that, it'll be thrown out of business, and Europe probably is moving towards that. I don't know enough, but Europe is probably the most forward in that direction. It's going to come.
Right. Thanks. Krishna, your question, please.
Sure, Venki. The question that I had is that, Kuntal, most of the things, what I understand is that it also requires a lot of control on the infrastructure, right? So, whether some of these techniques can be adopted from on-prem versus cloud environments, or are there additional challenges coming to?
They can be. So if your clouds, no, they can be, right. If your cloud service providers want to charge a small fee and do this, they can, because the clients might still benefit. Eventually, their cost might actually the bill that the client pays might eventually go down. See, in Accenture, we do in a services model. There, it definitely helps. But if you're asking, can a product company do this? They probably can, even though we have not worked on that model. I'm just like speaking from my gut feel. I could be wrong, but that's my gut feel.
Thank you.
There's one
Thanks
more
for all the
question.
questions. Yeah, please.
It's how to minimize the risks associated with LLM generated misinformation. May not be completely relevant to the topic, but if you have any thoughts on that.
I don't. There are so many researchers working on that, right? Not that I don't have a thought, but it's not it on the top of my mind. So I'd better refrain from. Yeah.
Okay. So that's a very nice politically correct way of getting out of a question. So
So my
I know
uncle is a doctor, right?
it's
My
kind of
uncle is a
fun.
doctor. My uncle is a doctor. So please blame him for this foul language. But he used to say this is cerebral constipation and oral diarrhea. So I don't want to get into that.
Thanks, Kuntal. I don't think there are any other questions on the chat box. We're also
Wonderful.
almost at the close of the hour. Any final questions from anyone? There doesn't seem to be one. So if there are no questions, so let me take this opportunity again to thank you, Kuntal, for taking the time to be on this call today and talking to us about a very important